Yes, it is very cold in Bangalore, so it's nice weather. So Learn Verilog and come fast to Bangalore. So today we gonna start. It's a date 6, and we will finish this one vector, and then the most interesting thing will start, and those are modules, procedures. So I'm very excited. I hope you are too. And if you are, then please like, because we need to have 50 likes in every video, right? So please like and give your contributions. So the first topic for today, and that is vector concatenation. So from the name only you can know concatenation means if you have some slices, okay, and if you wanna combine them, then that is we call concatenation, concatenations, right? Pronunciation I'm not sure about, but yeah, that's the thing. I hope you are getting it. So here they are explaining again to you all the theory, like what is happening, but and I'll also explain, but please let me know what this is. Can you recognize this? I have already explained this. So this is nothing but we are here declaring a 6-bit, because first is 6, and then what we have followed by the B. So B imply it's a binary, because in number system for all the first year, second year guys in BTech, for sure you have already gone through your number system, and for senior guys you also have done. So if you are still confusing, then you need to revise your number system again. So in number system we have many type of number systems like binary, hexadecimal, octadecimal, decimals. So B for binary, H for hexadecimal. We will also see some example from hexadecimal today, so that's why I'm bringing this thing in light. So it's a 6-bit binary number, and binary number is denoted by 11 and then 000. I hope you can convert it to a decimal number, right? That thing you need to know. I won't gonna explain here. That's your task. Number system, very important. Like it's the foundation or is the starting gate for digital electronics. Also, few of you, if you are finding issues with gate and those things and not, then your Boolean algebra need to be perfect before that. So this Boolean algebra and number system are like prerequisites for your digital electronics, and digital electronics is the prerequisite for your Verilog. So I hope you are getting the chronology. You need to first learn Boolean algebra, number system. These things I am explaining for those who are just starting your BTech. For senior guy, I know you know all those things. And then your digital electronics, and after digital electronics, some basics of programming, coding, and then the Verilog. But as I said, I will try my best to help you without any prerequisites, but again saying you need to know those prerequisites, basics. Okay. So these things they are explaining here, and how they are finding it out. They are finding it out from 2 slices of 3 bits binary number. So they are just concatenating these two, and they're getting a 6-bit. So that's the whole objective here. For example, see here this fellow, this one and this one. This is a 4-bit number. Can you tell me what this number is? Let me highlight it here. It is 4HA. What this is? Can you convert it to a decimal number or at least binary number? So as I said a while ago, H for hexadecimal, so it's a 4-bit hexadecimal, and hexadecimal are always 4-bit only. The minimum which is it is 4-bit. So it's a hexadecimal, and A imply nothing but your 10000. This is your A. So if you are confusing how these things coming, you need to complete your number system, right? Likewise, your B would be 1001, and then our F would be 1111. So these things I'm writing because I know how hexadecimal gonna represented. You also need to know that. So they are combining 2 4-bit number, and they are getting a 8-bit binary number. So that's how we concatenate things. There they are also giving us some other example, like what are the application of these things. Like we can use it for sweeping our 2 bits here and there, those things. So you please gonna read these things and let us do this example here. So most of the thing will be clear. So here in this example they are saying that, hey, you have 6 number here, actually A to F, 6 number. These are not hexadecimal, these are just variable, or you can say any data type, right? And here they are explaining actually you have 5-bit input vector, their input vector from A to F. So that means our A is, like if gonna write, then A is something which is a 5-bit binary number. They have not said it's a binary or hexadecimal, but this size is important, because anytime you're gonna concatenate two vector, we need to know the size. If it is 5 and 5, then only the output would be of 10 bit. So size is the important. So size they have explained here. It's a 5-bit input vector. And then what we need to do? We need to take 5-bit input vector. How many? 6. So total bit would be 30. But our output here is of 32 bits. So that means 30 and then 2 bits are remaining. So they are saying here the last 2 bits should be filled up by 2 1. So you can see here 2 1 gone filled up, because this will give you 30 bits, and the other 2 bit remaining will be 1 1. So that's our task. I hope the task is clear. Let's do it then. So they have given us some hints here. So what I gonna do, I want to assign. So for concatenation, these curly braces are used. So it's simple. So I'll write from the picture only. I can see I need to assign w, x, y, z to this fellow, this 6 fellow. So here I'll simply write w, x, y, z, and then w, x, y, z should get, like they should get assignment from a, b, c, d, e, f. What are the things inside is not necessary, because here for this problem size is important. So size is already defined. Inside I don't know what's the number. I'll get those number from the user later, whenever they will gonna use my module. My module means my circuits, right? But for now size is important. So that's why we don't know what's inside A, B, C, D, but we know those are 5-bit number. Again, we don't know what, like we know inside W a portion of A will go, inside W a portion of A will go, and also size are defined. So we know that here W is of 8 bit, X is of 8 bits. So total here we are having 32 bits. Here this 6 will make my 30 bits. So for other 2 bits, what we need to do, we need to manually write here. Now it is your task. You need to think now, at least for 10 seconds. Tell me, what should I write here? I need to insert here 2 1 bits. And how I am knowing this thing? Because here they have said already, right? Vector followed by 2 1 bits. So now to insert 2 1 bits, size is 2. These are hexadecimal, binary, or what? 2 1 bits. So they can be of any types, but if it is hexadecimal, and if I want to enter 2 1, then in hexadecimal I said you, right, the minimum would be 4. So if you give 1, actually you are giving 0 0 0 1. So 2 1 means 0 0 0 1, again 0 0 0 1. So it's a 8 bit. So hexadecimal for sure we can't give. Octadecimal is also there, but octadecimal need 3 minimum bits. So that means only one thing is remaining, and that is a binary. So we will write how? Think. How we gonna give this 1 1 1? Pause it, try to think what would be, and after that resume it. So I hope you have given a thought. So what would be? It would be 2 size binary, and what inside we have 1 1. So this thing we'll write here. So 2 and then this one, then it's a binary number of 1 1. And that's your answer. So submit it. They are not letting us go. Okay, what's the issue? We are getting error, and whenever you get error, now it's very important to see what's the error is there, because next time whenever you get the same error, you can quickly find the reason here. So here they are saying here near text B11 we are expecting a semicolon here. Anytime first time you see such kind of error, you probably don't know how to solve it. But for me, I am seeing it, and at 1 second, 1 click of second, I can know the solution, because I have the experience, right? I am solving it. That's why I know. Previously, sometime 1 year ago, 2 years ago, probably I got the same type of error and I have solved it. So that's why anytime you see any error, it's very important to see the error statement and make a kind of map in your mind. And those will come by practicing only. So don't worry, but I am just giving you a hands up. So here what is happening, actually space is not allowed. What I am giving here, right? So with this space, they are thinking it's some different thing, so space is not allowed. So after, let's submit, and I hope this time we'll get a success message. So in meantime, please like the video. If you still not, you need to. And great, we got a success message. So in this graphs, in waveform also, you might sometimes get confused what those waveforms are, how they are coming. These are, I said, these are random impulses they are giving, they are generating, and then they are checking these random impulses for my circuit which I've designed and for their reference circuit, and if they get a mismatch 0, then we are clear. But here we know this A, B, C, D, E, F are of 5-bit number, but here this waveform are not looking like a 5-bit number, right? They are giving a 0, they are giving a 1. Then how it is actually? See, they are actually helping us to visualize this nicely. So that's why this representation. For example, let me take this 1 as an example. So anytime they are giving 1 inside a F, and you remember 1 is not 1, like 1 you can write in your binary as this, right? Or let me take 2, so it will be more clear. Actually 1 will little bit confusing. Yeah, you can represent as 1 1, but we know that F is a 5-bit number. From where I am knowing, in a question only it is written, so that means the left side 3-bit would be 0 0, so it's a 0 0 0 1 1. So probably if you want to see the expanded view of this waveform, you will see 5 waveforms here. 3 would be 0 and your 2 would be of 1. So this is the thing. But if they're gonna give all the waveform here explicitly, it will become very clumsy. So next problem, they are saying us that, hey, given 8-bit, 8-bit is there, you need to reverse it. Okay, you need to reverse the bit order. So I hope we have done similar kind of one problem in few days ago, so we can do it quickly, and I can skip it also, but here I have one concept to help you out. So here I can directly write like this, right? Assign my out equal to reversal of in. So most of you might be thinking that, hey, let's do one thing, write it in reverse form, like 0 and then colon 7. But this is not allowed in Verilog. In one of my previous episode, I have said you can't change the directions. This means that here the 7-bit would be a lowmost bit and 0 would be a MSB. And here you are saying here 0 is your LSB and your 7 as MSB. So logically speaking, you have reversed it, but this is not allowed in Verilog, right? So we can't go with this option. We can submit also, but you will see some error would be there. So this is not the correct way to go forward. Then we have another alternative way to solve this problem. See, they are giving you. So this error statement is also important. Please see it. Sometime unforgetfully, if you do such kind of error, by seeing this error message, you will know, hey, we are doing this error. So here they are saying part select direction is opposite. I said not, you can't change the direction. So they are saying the direction is opposite, so it's not allowed. So yeah, this is eliminated. This option is not allowed. Another option would be, hey, let's do one thing. Let's write out the lowest most bit. We can select the part, right? So I am selecting the lowest most bit of my out equal to in and the highest most bit and comma. And likewise, I'll take the next out 1 and I'll assign it to in 6. I can do it, but I need to write it 8 times. You can do it and it's a perfect answer, but again, it's not an efficient answer. It will take a lot of time. And likewise, we solved in our previous example in 2 or 3 days before. But here, as we have learned concatenations, so we will use that one. With concatenation, you can write only one assign and you can do your job. So here what we'll write out equal to, for that concatenation we need to use curly braces, and inside curly braces what I'll do, I'll write in 7. So in 7, if I write in 7 then comma, then in 6 comma, and till in 0, I am not doing the perfect thing because I want to reverse it, right? So this is my maximum MSB. This MSB should get assigned to LSB of my out. But how it works is that what will happen actually, this fellow will get assigned to out 7. Then this fellow will get assigned to your out 6. So we are not reversing it, right? So to reverse it, actually we need to write it in reverse order, and that is start from 0, then go to 1, and then go till the time we finish the 8 bits. So let me do it. So I have written it right like this. So I hope you are getting these things, and then a semicolon, and then submit, and see, we got a success message. So let's go to, without time wasting, next, and that is vector 4. So here what they are saying, the concatenation operator allowed concatenation together vector to form a larger vector, right? But sometimes you want to do the same thing. For example, here this example, what they are trying to do here, they are trying to do a equal to b how many times? 1 2 3 4 5 6 times. So if b is a 3-bit number, 4-bit number, or 1-bit number, for example, b is a 1-bit number or 2-bit number, 3-bit number, 101. So they want to make their a equal to 101 101 101 like this. They want to replicate b for 6 times. So you can do like this, it's okay. And why we are doing, we have an application, I'll tell you, but the problem is that you need to write b 6 times. If somebody say 100 times, then you need to type b 100 times. It's a time wasting thing, right? We should have some methodology or some way how by which we can do the replication things, and that is actually done by like this. So for example, this a could be written in easy way, and that is how many times? 6 times, and then comma b. So b and 6 is looking like same, so b will get replicated 6 times. Now here they have given some examples also like this. So they have given some examples. So here what is happening, abc will come 2 times, here this thing will come 5 times. So I hope you are getting these things. So now the question is that what's the application of it? So in application actually will get from this question solving. So they are saying anytime, there are many other applications, but one of the major application, and that is anytime you want to extend your sign bit. Now many of my junior student, first second year, probably senior student, will say what is mean by sign bit. In binary we need to have signs, right? Plus minus. So in binary, I am not explaining everything. You need, if you are confused, for sure you go to number system again, but roughly saying, to recall the things, the leftmost bit, if it is a sign bit, then a leftmost bit will give you the sign. So if it is 1, then your number is a negative. If it is 0, then your number is a positive one. So for example, they are saying here, for example, this one. So 1 0 1 and then another one, right? So this leftmost will give you sign, and then the rest will give you the magnitude of your number. So 101 is 3, and as it is 1, so it's minus. But this is a 4-bit number. But sometimes there are few occasions when you need to extend 4-bit to 32-bit, 64-bit. You need to do it. So they are saying extend it to a 8-bit number. So if we want to extend it to 8-bit number, we need to keep our magnitude same. We need to keep our sign also same. Magnitude is 3 only, so 3 will be defined as 101. And if it is an unsigned number, then rest of the thing we will fill up with 0, right? Or if it is a positive number, we'll fill it up with 0, because 0 leftmost 0 imply it's a positive number. But as it is a negative number, so the leftmost remaining bits we will fill it up with 1. So any number of 1 which will make the total equal to 8 bits. So that time we will use this shortcut, that hey, replicate it how many times you need it, right? So in the question here, what we need to do, we need to actually extend our 8-bit number to 32-bit number. So if our number is 8-bit, we're gonna go to 32-bit. That means 24 extra bit we need to add. So just think, if we don't have this shortcut, then 24 times we need to type those ugly thing, right? So that's why it's very important. So that's our task. If you know it, then pause and solve it. Otherwise, see how I'm doing it. They have given us some example also, but I'll just, not example but hint, but I'll just hide it. So what we're gonna do, we're gonna do 24 time multiplication or replication, right? But we're gonna do 24 time replication of what? Of which bit? Yes, the sign bit, right? And the sign bit will be the leftmost bit. So for example, here your in is of 7 0, 8-bit number. So the leftmost bit would be the sign bit. And how to access the leftmost bit? If you also remember that your leftmost bit is the most significant bit, or you can just need to access the most significant bit, and which is 7, because this is nothing but you have something like this 4 dot 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 and up to 7. These are your 7 bits. So this bit, the leftmost bit, will give me the sign. So that's why I need to multiply this bit into 24 times. So that's why here I will write in, then the 7. So let me do that thing. So I'll write in and then 7 and then braces close and then comma. After I have extended, I need to add the magnitude part, right? So magnitude part will be our in only. So in is of 8 bit, in is of 8 bit, and then a 24 bit. So in total we have 32 bits, and your out is already defined as 32 bits. So we have done our job. So hopefully we'll get a success message. So let us submit. And if you are feeling any difficulty, comment it down. If you are feeling any difficulty because of the theory which I have mentioned, Boolean algebra, number system, or digital electronics, there currently I can't help you, but from NPTEL, from your friends, you can take the help, right? Okay, we have a issue, and we need to know what the issue is, and it is in the line number 5. They are again expecting some semicolon or some curly braces. So let us go to line number 5. This is our line number 5. From my initial view, I can't see any issue here. Okay, so we are missing something. Here is actually it is curly braces, right? And we are giving a single braces. So just map this, like read this error statement. And I know you can't map all the error statement with the answer, but roughly you just read all the error message anytime you get it, and then only solve it, right? Don't need to note down anywhere, and that thing's not required. Just you need to read it sometime, like, and by experience, by solving 100 questions, and we gonna, this HDL beats actually have many questions. So by practice only you will get an idea, and in future, in second only, you can find out the solution why the error is coming. So don't worry. Okay, we are getting again a issue, and the time they are saying after text comma they are expecting a curly braces actually. So what's the error? I think here also we need to have a curly braces. So these are the syntax error actually. Let me submit it, and I saw it, and we got a success message, right? That's great. So actually we were doing this syntax wrongly, and the syntax is this one, right? Here they have shown actually this is the example. So if you have seen this example, then in one go only we have had solved this one. Okay, so this one, okay, let me see if I can quickly solve. I'll solve, otherwise you need to solve it. I won't gonna do it. Given 5 1-bit signals, 5 1-bit signal A B C D E, compute all 25 pairwise 1-bit comparison in the 25-bit output vector. The output should be 1 if the 2 bits being compared are equal. That's an interesting one, but it is quite late in my side, so I'm not gonna do it. You do it. If you don't find the answer, comment it down, and if you have solved it, then in comment please provide the solution, so the people who are commenting, they will get the solution, right? So now is the time for the next question. Before that, the answer for the last day question. And thanks a lot for everyone who are keep on commenting, doing your bit to help my channel to grow, also yourself to grow and your friends to grow, because you are giving the answers, and which will for sure you'll retain those answers for lot of more time. Okay, so the main difference between the behavioral domain and the structural domain is that in structural domain, as name suggests, we need to give a structure. In behavioral domain, we do everything kind of algorithm. So we are just telling our compiler that, hey, you need to do this thing. This is the AND gate, this is a NOT gate, this is those things, this is the memory block. But explicitly we are not telling how in the gate level we gonna do it, right? As I said, if we write A and B, that A and B can be implemented using many type of gate. NAND gate also we can do it. So who will tell us those description? And those are given when we convert the behavioral domain to the structural domain. So there we might be tell our compiler that, hey, we're gonna do A and B but using a NAND gate, right? Also there we will insert everything which are we know, like we will insert a flip-flop. Probably we have a module of flip-flop in the structural domain where we will define how a flip-flop got manufactured from the using the gates, because if you know a flip-flop are made up out of NAND gate or AND gates, right? We will use a mask, probably we will have a new module of mask, right? And there we will tell how a marks got formed, 1:4 marks, 4:1 marks, decoder, right? So we need to give all the explanation in a structural domain. So that's the difference. And mostly anytime you're gonna give the answer this type of question in interview, try to use your own word, get the knowledge concept, and then for example here I am telling you this answer, right? This answer is from my own understanding. I understood the concept and then I am forming the answer. Likewise you should give the answer. Don't tell anything which is already written in the internet or in the book, just reading the statement. These things they also know, but you need to give the answer in a way so that they know you have digested the concept and now you are forming the answer from your insights. So that's the way you should give answer. Those answer need to be 100% true, 100% foolproof, but if you can consume and digest a concept 80% and deliver 70%, then also is better, best than just reading out the statement, right? What's the full form of BCD number system? You just said BCD is binary coded decimal number. This is not the answer. You got, I think, what I am trying to explain. So we'll see in our next video. Like the video, subscribe if you haven't. You need to, you are doing a crime. Okay, so keep smiling and I'll see you in our next video. Till then, tata, bye bye.